equations. So today we're not just looking at how to write equations, but we're also looking, or how to solve equations, we're also looking how to write them as well. So to start off with, I kind of want to take a look at how we can turn words into mathematical symbols. So this chart's really good to have as you're going through and working on word problems because it says, hey, if you see this number, use this symbol. So for example, if you're reading through a word problem, it says added to, increased by, more than, some, addition to, all of those mean you need to add, and that's really hard to see. Okay, all of those mean you need to add. If it says subtracted from, decreased by, less than, difference, taken away from, all of those mean you need to subtract. Likewise, multiply by, product, times, all of those imply multiplication. Now we have a couple of symbols for multiplication, so I'm writing them all there. That should be an X. Okay, next, quotient divided by, split into, that simply means divided. So remember that fractions can be considered dividing as well. So if we're talking about something squared, if we have something squared, so we're going to take a number and we're going to raise it to the second power. So a squared is really the same as a times a. Then if we're talking about a number cubed, that's really the same as a to the third power, which is the same as a times a times a. Okay, something to the nth power, we're going to take a number and raise it to the nth power. So that means that it is being multiplied by itself n times. Okay, then finally, is the same as or equals to? That means you need to put in an equal sign, okay? That's where the equal sign comes in. So what we're going to do is we're going to practice translating some phrases into mathematical terms, okay, into equations. So the sum of a number and 16 is 32. So whenever I see the letters a number, I'm going to use the variable x. So the sum of a number, well, sum means adding. So a number plus 16 is going to be equal to 32. The sum of a number and 11 is 42. Again, my number that's unknown is x. Then we're adding it to 11, and we want that to equal 42. The product of 16 and a number is equal to 32. Well, the product, that means times. So 16 times our number that we don't know is equal to 32. Now, when you see 16 times x, a lot of times that's written simply as 16x. So if there's no operation written, that means that it's being multiplied. So taking a look at number 4, the product of 12 and a number is equal to 48. So that's the same thing. 12 times x, which I can just write as 12x, is equal to 48. Taking a look at number 5, the quotient of a number and 16 is 32. So we have to look at the order in which it's written. So the quotient of a number and 16 is 32. So that means we need to take our number that we don't know, and that's going to be divided by 16. I'm choosing to use the fraction symbol. You could use the divided by symbol as well, and that's going to be equal to 32. The quotient of 12 and a number is 24. So that means 12 is going to go on top. On the bottom is going to be my number that I don't know, and that's going to be equal to 24. Taking a look at number 7, the fourth power of a number is 16. So the number we don't know is x. And when we're talking to the fourth power, that means we're going to multiply x by itself 4 times. So I'm going to put the little number 4 up there, and that's going to be equal to 16. So x to the fourth power is equal to 16. The third power, which also could be said as cubed of a number, is 27. So we're taking x and we're raising it to the third power, and that's going to be equal to 27. The difference of a number and 16, again, difference is another one where we have to pay attention to the order. So then we have x, and we're going to subtract 16, and that's going to be equal to 32, because the difference between the number and 16 is 32. So then for this one, 14 less than a number is 3. So this less than means implies that we have to take the number, subtract off 14, and have it equal 3. So I'm taking the number and I'm taking 14 less than it. So I'm subtracting off 14, and that's going to be equal to 3. Okay. So next, let's go ahead and let's take a look at some of these word problems kind of in action where we're going to sometimes apply some of this. So a rock climbing gym charges non-members $16 per day to use the gym and $8 per day for equipment. Members pay a yearly fee of $450. So no matter how many days they go, it's going to be $450. And $6 per day for equipment rental. So we want to write and solve, oh, goodness gracious, write and solve an equation to find out how many times you need to go to justify being a member. So what I'm going to do, all these per days, I'm going to let X represent the actual number of days that I go to the gym. So if I'm a non-member, I go $16 for every X day I go to get in. Also, I have to pay $8 for every X day that I go in to rent the equipment. However, if I am a member, I pay a one-time fee of $450, and it doesn't matter how many days I go in. But, however, for every X day I go in, I still have to pay the $6. So this is helping budgeting if it's worth it to get a membership versus just paying the daily fee. Kind of like if you go to the Twins game, is it worth buying season tickets or not? Okay, do you go to enough games? So 16x plus 8x, you add those together and you're going to get 24x. And that's going to be equal to 6x plus 450. So now what we're going to do is I need to get my x's on the same side. So I'm going to go ahead and subtract 6x from both sides. 24x minus 6x is going to give me 18x. And that's going to be equal to 450. Divide both sides by 18, and I end up getting that x is equal to 25. And then x is representative of days. Whenever we have a word problem, we need to label it. So if I go to the gym 25 days, it costs the same to have a membership versus paying daily. If I go 26 days, I definitely want to invest in a membership. So let's take a look at number 12. On July 20th, 1969, Neil Armstrong stepped on the surface of the moon. On the moon, his suit and life support weighed 33 pounds. It's math class. Numbers are going to be important. An item's weight on the moon is about 1/6 its weight on Earth. So we want to know the weight of his suit and life support backpack on Earth. So I'm going to let X represent the weight on Earth. Okay, so what I need to do is take the weight on Earth, which is X, and it's going to be 1/6 of that weight. And that's going to be equal to 33. So then, now I have this 1/6 X. Sorry about that announcement there. So since I have the 1/6 X, what I need to do is look at this and I need to multiply by the reciprocal like we did yesterday when we had fractions. So what I have is x is equal to, this is really going to be the same as 33 times 6. And 33 times 6 is 198 pounds for number 12. Let's take a look at number 13. So in a recent survey of girls, 225, or about 9/20ths of those surveyed, said they talk on the telephone while they watch television. About how many girls were surveyed? So 9/20ths of the total girls surveyed. So I'm going to let X represent the total girls surveyed. So if I take the total number of girls surveyed, I need to multiply it by 9/20ths, because that's how many said that they watched television while they talked on the phone. And that ended up being 225. So again, we have a fraction, 9/20. So what I need to do is multiply by the reciprocal. Again, whenever we have a fraction, we multiply by the reciprocal. So what this is really going to be is these all cancel out. So I'm going to have 225 times 20, and then I'm going to divide it by 9. And when I do that, I get 101. That can't be right. So let's take a look. So what we're going to do is we're going to do 225 times 20 divided by 9. Goodness gracious. So that's 500 girls. So there were 500 total girls that were surveyed. All right, let's take a look at this last one. The discharge of a river equals the product of its width, its average depth, and speed. At one location in St. Louis, the Mississippi River is 533 meters wide. Okay, so that width is going to be equal to, or the discharge, the discharge, it says, is 3,198. So the discharge is going to be equal to the product of its width. Now that's multiplying. The width is 533. Its speed, which is 0.6, and its depth, which we don't know. So I'm going to label that D. So now we need to go through and multiply. So we're going to do 533 times 0.6. And when we multiply that together, we get 319.8. So we get 3,198. So now we need to solve that for D. So since that's being multiplied by D, I'm going to divide both sides by 319.8. So then I end up getting, once I divide that D is equal to 10. So now I need to figure out what my label is going to be. Well, since the width is being measured in meters, the depth will also be measured in meters. So that concludes your note video for today. Go ahead and show me your completed note sheet once you are done. Thanks for listening.